This lab will be on circuits. We'll focus on two circuit elements, resistors and capacitors. Resistors we draw as a zigzag line. When we apply a voltage across a resistor, current will flow from the more positive to more negative side of the resistor. The amount of current is determined by Ohm's law. Capacitors are drawn as two parallel plates. When we apply a voltage across a capacitor, a charge builds up on one plate and an opposite charge on the other. The amount of charge is the capacitance times the voltage applied. These basic circuit components can combine to create larger circuits with an effective resistance or capacitance. We'll look at two ways components can combine, in series and in parallel. In series means one after the other, where the same amount of charge flowing through the first component has to then also flow through the other. So for individual resistors, the voltage across each one is determined by that current times the individual resistances. In parallel means that you apply the same voltage across both of the components, but different amounts of current could flow through either one. The current through either resistor is determined again by Ohm's law. Similarly, applying a voltage across capacitors in series means that the same charge will be built up on either capacitor. Then the voltages across each individual capacitor will be determined by that charge and the individual capacitances. Capacitors in parallel will each have the same voltage across them, but will each have different charges built up. The charge will be the voltage times the capacitance. So in this lab, we'll investigate a few basic circuit concepts. Ohm's law by measuring the current flowing through different resistances when we apply a constant voltage. Series circuits by measuring the voltages dropped across components placed in series. Parallel resistances by measuring the total current flowing through resistors in parallel. And parallel capacitances by discharging one capacitor through another and measuring the voltage remaining across both. To do this, we'll need to be familiar with a few techniques: how to build a circuit on a breadboard, how to measure voltages, and how to measure currents. In this lab, you'll use what's called a breadboard to connect your circuit elements. Each set of holes on the breadboard is electrically connected, so all of the holes in each set are held at the same electric potential. To connect a basic circuit, say to put a voltage across a resistor, you'll snap one of the resistors across two different sets of holes and insert the leads of your voltage source into either side. When you do this, current will flow from the more positive lead through the resistor and into the more negative lead. The amount of current is determined by Ohm's law. To measure the voltage dropped across this resistor, just place the two leads of the multimeter into the two holes whose potential difference you want to measure. To measure the current through the circuit, all of the current has to go through the multimeter, so we'll put the multimeter in series with the part of the circuit we're measuring the current through. Set the multimeter to measure current. In this setting, the multimeter has a very low resistance, and you can ignore its effect on the circuit you're measuring.